Hi, everybody. My name's Kayla. As you know, I'm a master's student in the Environmental and Life Sciences program. My presentation is called Trees for Turkeys, and it's about how I'm using GIS to help map wild turkey roost sites. I studied the eastern wild turkey. This species was reintroduced to Ontario in the 1980s and 1990s. These days, populations are doing pretty well. You can find turkeys around Peterborough, and this area represents the northern part of their range, although the range has been expanding northward over the past decade or so. Now, what's interesting about turkeys around here is that they experience a variety of environmental conditions, like these turkeys walking through the snow in winter. So we have opportunities to study turkey movements and habitat use and ecology in a part of the range where they have this big variety of conditions. Now, how many of you have seen turkeys before? Awesome. Okay, this is great. So if you're like me, probably you just see turkeys as you're driving out in the country and you look into a field and there's a bunch of turkeys standing near the back of the field. That's how a lot of my turkey observations are. Certainly before I started this project, that was pretty much all of my turkey observations. I never really thought much about what the turkeys might be doing or where they might be outside that brief moment that I see them. But now that I'm studying them, I actually have the opportunity to look into that and figure out, well, where are they the rest of the time? And so how am I doing that? Well, I am tracking some turkeys, and I'm tracking some wild turkeys around here. There I am in the field tracking turkeys. I have special equipment for that. And you know who else has special equipment? That would be the turkeys. So some of the turkeys are wearing special tracker tags. We give them a harness so that they wear these tags like a little backpack. And I actually brought in one of the tags here so you can see this is what it looks like. This is the size of it. And yeah, we just use like paracord that goes through 2 loops here. Make them a little backpack. Yeah, this is Hazel, the hen. She's wearing her tag. And that horizontal line there, that's the tag antenna. So these tags are nice because they still allow turkeys to walk and fly and do all their normal turkey activities. It doesn't really get in the way. I like to joke that it's wearable tech, which is all the rage right now. And so these are very trendy turkeys. What's nice is that these tags allow me to get location information about the turkeys and figure out where they go. So here's how that works. First of all, the tags communicate with satellites and they get a GPS location for the turkey at predetermined time intervals. And this is great information, this is great data, but I can't use it until I transfer it off the tag. Luckily, I can do a somewhat remote download of the data from the tag onto a receiver. So with an antenna and receiver, if I'm within like 150 meters of a turkey tag, that equipment will communicate with the tag and download the data from the tag onto the receiver. And then from there, I can connect the receiver to my computer and transfer the data onto my computer. And then I can look at maps that show me where the turkeys have been. As I was looking at these maps and looking at these turkey location points, I noticed something kind of interesting. And that was that the turkeys seem to have preferred roost sites. Now, turkeys do a behavior called roosting, in which they fly up into the trees at night and they rest there for the night. So yes, turkeys can fly. And in the morning, they fly back down and they pretty much spend the rest of the day down on the ground. But what I saw when I looked at these maps was that there would be a lot of turkey location points sort of at certain sites, but not at other sites. So it seemed like maybe they had some preferences for where they roosted. Additionally, I saw that the sites they preferred in winter were somewhat different from the sites that they preferred in summer. So there's potentially a seasonal shift in roost sites. All of this got me wondering, what might influence a turkey's selection of a roost site? Why might a turkey choose one tree to roost in instead of another tree? So one factor that I would like to look at for my project is microclimate. Microclimate is just another word for the weather conditions or the climate conditions at a very specific location. And in this case, I'm interested in the turkey roost trees. So it's possible that turkeys are choosing trees that offer a favorable microclimate. maybe shelter from the wind on a cold, windy winter night, or maybe a slightly cooler temperature on a hot summer night. I'm not sure. That's why I want to look into it. And I want to look at microclimate at these roost trees compared to trees that the turkeys are not roosting in, and see if there's anything going on, if there's any sort of difference. But in order to do that, I had to map out all of turkey sites where they were roosting. This is where GIS came into play. So I used ArcGIS Pro to map out a bunch of turkey roost locations. And so this map here is showing turkey roost locations coming from turkeys that were tagged and tracked in 2017 to 2019 as part of a previous program. And then in 2022, which is the step that I've been doing. And so I had all of this information coming from turkeys from about 4 different flocks, 2 flocks near Peterborough, 2 flocks to the east. And I had a lot of information, a lot of location data. So I filtered it out so that I had 1 location per turkey per night. And then I further categorized it by season. And so here I'm showing summer roost sites, which are the sort of pinkish dots, and then winter roost sites as the light blue. I'm interested in summer and winter because those are the times of the year when the turkeys are dealing with more extreme climate conditions. And therefore, those are the times of the year where maybe this microclimate at the roost site is more important to a turkey. So I've mapped that all out. And I was working under the assumption that in the middle of the night, a turkey is roosting, and therefore a turkey location at night is representative of a roost tree location. So zooming in on a portion of the map, this is a bunch of summertime roost locations from turkeys. And just some things to point out here, I often get clusters of locations, like in this circle, where there's lots of different turkey points all together, but then sometimes I get one just off on its own, like in that diamond there. So I was looking at this and going, okay, I wonder what's going on there. And I decided I am more interested in the clusters for 2 main reasons. First of all, when I have a cluster like this, I am pretty sure that that means the turkeys like the site. They are making multiple visits and or multiple turkeys are going to the site. So it's like, okay, this seems to be a pretty good roost site. I'm interested in this. And then secondly, the clusters are less likely to be GPS spatial error. When I have a point like this that's off on its own, there is a chance that that's not a totally accurate point. It could be that the turkey was actually closer to the trees, but if the tag couldn't communicate with enough satellites, it can reduce the spatial accuracy, and therefore the coordinate that gets saved on the tag is like out here in the fields, even if that's not what the turkey was. So when I get those single locations, I'm just a little more wary of them. And so I'm more confident and more interested in the clusters. But there's a bit of a challenge that comes with working with these clusters. And that is when it's time for me to go out into the field and measure microclimate, which point in the cluster do I go to in order to measure things? So I used a couple tools in GIS to help deal with this problem. First, I used something called density-based clustering. And this is a tool that looks at how close together the points are and how many points are there. And then it'll group them together based on those factors. So in this case, and you can define how many points are required to constitute a cluster, and you can define how far apart those points can be. So you do have some control over this. And it groups them together and it gives them all, each cluster gets a certain color and a certain ID. Points that are too isolated to be grouped into a cluster, they kind of just get sort of ignored. They don't go to a cluster, they just sit out here and they're the light gray dots on the map. So I ended up kind of figuring out which sites have enough points to be a cluster and therefore to be of interest to me. And then from there, I used another tool called Summarize, Center, and Dispersion. This tool can tell you a few different things. Obviously, it can tell you the center of a cluster. It can also tell you the mean and median, as well as dispersion, which is sort of how spread out are the points in the cluster. And so what I'm showing here with these yellow markers, those are the centers of the different clusters. So when I clean up the map a little bit, get rid of all those location points, I'm left with just these markers showing the center of my location clusters. And this is great because I can export these coordinates and put them onto a GPS or maybe use something like field maps now that I know about that. But either way, I now have a distinct location for each cluster. That's where I can go to measure microclimate. So that's a big help there in sorting out where I need to go in order to do my research. As a summary, I'm a beginner to GIS. This is all very new to me. Magic has been a really good resource and a big help. But this is just to say that even a beginner can start to make use of GIS. Just start small. Just learn a couple tools at a time. That's all you have to do. And yeah, before you know it, you could be up here presenting at the next GIS day. Okay, thanks for your attention.